Hi, I'm Peyton Dagg, and welcome to Project Str-Eng. I didn't know anything about engineering or physics, and I'm on a mission to learn from industry professionals about what it takes to build structures around us, whether it be our apartment buildings or the bridges we cross on the way to work. Today's episode will be on friction. History. Leonardo da Vinci discovered the two classic laws of friction, well before our friend Isaac Newton even defined what a force was.
Da Vinci?
Leonardo da Vinci was not only a remarkable artist, but an avid scientist and inventor. He made numerous sketches and notes on scientific topics, including the concept of friction. Da Vinci argued that the force of friction acting between two surfaces is proportional to the load pressing the two surfaces together. Did you know that friction can generate static electricity? And this is the same static electricity that makes lightning in thunderstorms. A thunderstorm generates a big static electric charge as ice particles collide in the storm clouds. And through friction, lightning bolts are made to scare our pets and loved ones. Anyways, Da Vinci noticed that the force needed to move an object increased as the angle of the incline became steeper. Da Vinci invented the idea of tribology, which is derived from the Greek word tribos, which means rubbing or sliding. While Leonardo da Vinci's contributions to the scientific understanding of friction were significant, it's essential to acknowledge that he did not develop the formal theory of friction as it is today. This is when our good friend Isaac Newton comes into play. Hi, Isaac.
Hey, little mama.
Isaac Newton's third law, which we promised to speak about, states that for every action there is an equal and opposite reaction. In the context of friction, this means that the force of friction acting upon an object in contact with the surface is matched by an equal and opposite force exerted by the object on the surface. This reactive force is what prevents objects from simply passing through each other. I had a chat with my friend Peter, who explained what friction is to me. The interview.
Hello?
Hello? Peter? Where are you? You're supposed to be here at 10.
Yeah, no, sorry, I got caught in bike traffic. What do you want to ask me?
Okay, whatever. What is friction?
Okay, I'm going to put you on speaker. So friction is a force. It's the force when two objects are in contact with each other. It's the force that opposes the sliding of the two members. When you have low friction, the objects want to slide easily. When you have high friction, the objects don't want to slide. An example of this would be a hockey puck on ice versus a hockey puck on carpet. When you shoot the hockey puck on carpet, it has high friction and the hockey puck wants to stop a lot sooner than if you have a hockey puck on ice where it wants to slide. Whoa, there's no bike lane! There are two things that affect friction. You have the force that's between the two objects, which is called the normal force. Think about this as a squeezing force. Another example of this would be a weight of an object acting on another element. So for instance, an aquarium that is empty, if you're trying to push that aquarium when it's empty, it's easier to slide on the surface than when the aquarium is full of water and you're trying to push the aquarium. The second thing that affects friction is the surface roughness, which we call in structural engineering the coefficient of friction. The surface roughness is how rough the surface is. So a surface that is really rough, for instance on sandpaper, is going to be harder for the object to slide. Whereas if the surface is very smooth, like Teflon or plastic, it's going to be a lot easier for the object to move. Oh, bug in my mouth. The last thing I just want to explain with friction is the difference between static friction and kinetic friction. Static friction involves objects that are not moving, whereas kinetic friction involves objects that are in movement. Friction is typically lower when objects are in movement.
How do we use friction in everyday life?
So friction is used everywhere in daily life whenever we have two surfaces in contact with each other. Some examples of this might be bike brakes. So the more you squeeze a bike brake, the more you're going to stop. Another example of this is in non-stick cookware. In non-stick cookware, we might use surfaces like Teflon. Teflon is very slippery and doesn't cause our food to stick on the pan. The Teflon has a low coefficient of friction. Another example that I can think of is rubber at the bottom of your keyboard. So you want your keyboard not to slide, and so they put those little rubber pieces at the bottom of your keyboard. Now they don't put the rubber pieces on the bottom of the mouse because you want your mouse to slide. However, the keyboard you want to be stationary And so they put the rubber pieces at the bottom of the keyboard. Another example would be on a slide. So on a slide in a playground, you want the slide to be slippery. So you're going to have a smooth surface like plastic or metal.
How do you use friction in structural engineering?
So friction is used in structural engineering when we either want an object to slide or when we don't want an object to slide. An example of this would be in retaining wall construction. Retaining walls, we do not want them to slide, and so we ensure that the friction at the bottom of the wall can withstand the forces applied to the back of the wall from the retained soil. Another example of this, when we want something to slide, would be bridge sliding. And so when we want to slide a bridge into place or move an object in general in structural engineering, we will want to use material that has low coefficient of friction. Good options would be to grease two surfaces together or use rollers or even Teflon to ensure that the friction is low so that the object can slide easier. Going up a hill.
Why did you want to be an engineer?
Ever since I was little, I've always enjoyed building things. I'm curious and inquisitive, and I've always enjoyed problem solving. When I was little, I enjoyed things like Lego and mechanics and just putting things together. I've always been good at attention to detail and math, and I think all of these things are good attributes of an engineer. And I'm really looking forward to using those skills in the future to continually learn and to build myself as an engineer. Going down a hill.
And what's your favorite formula?
My favorite equation are the equations of static equilibrium. Static equilibrium tells us how forces are distributed in a static system. A static system is a system that is not moving. This tells us that when a force is applied, we have equal and opposite forces acting in the opposite direction. A good example of this would be a table. When you have the weight of a table, we have equal and opposite forces acting through the legs to keep the table in static equilibrium. Okay, coming up to the office. Hold on.
So basically, friction is the resistance that one surface or object encounters when moving over another. Friction is a force that resists the sliding, rolling, or moving of objects on solid surfaces or other objects. Newton's third law applies to friction, that the force of friction on an object is acting upon another object in both equal and opposite force. It is essential for traction between tires and road surfaces to prevent slipping and sliding. Lubricants, such as oils or greases, are used to minimize friction between objects and surfaces. That concludes this episode on friction. A special thank you to Peter for teaching me about what friction is, and a special thank you to you for sticking around till the end of the video. Like and subscribe to see more of me and my engineer friends who will teach us both about structural engineering. I'm Peyton Dagg, and this was another episode of Project Str-Eng. Don't forget to enjoy the process.
All right, sorry I'm late. Let's start this interview.
I've got everything I need.